The launcher uses a spring mechanism to store elastic potential energy when compressed. Upon release, this energy is converted into kinetic energy to launch the ping-pong ball from a height of 0.124 meter. The ball then follows projectile motion under the influence of gravity, demonstrating the application of dynamic mechanics of motion.
Or launched into the air and moving under the effect of gravity. In this project, a ping-pong ball is launched using a spring mechanism, and its motion is analyzed as a projectile. The launcher converts elastic potential energy stored in the spring into kinetic energy, which causes the ball to move forward and follow a curved path. This spring design challenge helps students understand the relationship between force, energy, launch angle, and range in projectile motion. By designing and testing a ping-pong launcher, the theoretical concepts such as Newton's law, conservation of energy, and kinematic equations can be applied to a real physical system. The objective of this assignment is to design and construct a spring-powered ping-pong ball launcher, to study the motion of a projectile launch at different angles, to compare theoretical calculations with experimental results, to apply conservation of energy and projectile motion equations to predict the range of the ball, and to understand how spring compression, launch angle, and initial velocity affect projectile motion.
The launcher uses a spring mechanism to store elastic potential energy when compressed. Upon release, this energy is converted into kinetic energy to launch the ping-pong ball from a height of 0.124 m. The ball then follows projectile motion under the influence of gravity, demonstrating the application of dynamics and mechanics of motion principles. The launcher system is based on the principles of conservation of energy and projectile motion. The elastic potential energy stored in the compressed spring is converted into kinetic energy, which determines the initial velocity of the ping-pong ball. The subsequent motion of the ball is analyzed using kinematic equations, where horizontal motion occurs at constant velocity and vertical motion is affected by gravitational acceleration.
Hi, my name is Nuriliana and I'm gonna explain how to find the spring constant, which is K, by using the Hooke's law experiment. In this experiment, we use a different force which is applied to the spring by using a different weight compared to the elongation. The graph below is force against extension is drawn based on the result. From the graph, we can determine the spring constant K by calculate the gradient of the graph, and we get 250 Newton per meter. For the next slide, I'm gonna explain how to find the initial launch velocity by using the projectile motion equation. So first, we need to resolve the initial velocity to vertical and horizontal components since the ball is launched at angle 45 degree. And we continue rearrange the equation to find the initial velocity.
And corporations are correct. Overall, this experiment helped us understand how a spring launcher works and how physics produce energy and projectile motion affect the path of the